All right, so let's go to the next step. In the previous step, we learned how to factor simple trinomials. Now, a simple trinomial is a trinomial that's in the standard form of ax squared plus bx plus c, but a must equal 1. So a simple trinomial was actually just x squared plus bx plus c. A complex trinomial is ax squared plus bx plus c. However, in this case, a is never equal to 1, because if it's 1, that means it's a simple trinomial. So in our case, complex trinomial is ax squared plus bx plus c, where a does not equal to 1. So now we have a difference between those two, and they're going to be handled slightly differently. So let's try this out. Well, let's start with a little bit of a warm-up first. So we're going to start off, and we are given this initial set of binomials, 2x plus 3 and x minus 4. When we see this start up, these things are already in what we call factored form. Our goal is to, in this case, expand and simplify. And we're going to expand it into expanded form. And all that means is multiply, 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 collect your like terms, and simplify. So they were already nice enough to give us the first step. So now let's use our distribution, our distributive property, and multiply our way through these. So we have 2x times x, that's going to give us 2x squared. 2x times negative 4, that's minus 8x. Over on the next set, we have 3 times x, so that's 3x. And 3 times negative 4, that's negative 12. We collect our like terms. To simplify everything, we only have 1x squared, so that's just going to leave that alone. And then we have negative 8x plus 3x. That's the same as negative 5x. And then the negative 12, the constant's all on its own. This is our fully expanded form. Now, our goal in this lesson is to take this fully expanded form and reverse it back up into factored form. Now, if you've noticed throughout this entire unit, that's what we've been doing. We've just basically been going back and forth between expanded to factored form or factored form to expanded form. It depends on what our needs are in a given question. So it says, consider the operations working backwards in order to go from standard form to factored form. How do we get from this state back up here? Well, we see that from this negative 5x, it came from adding this negative 8x and this positive 3x. Those were then broken down into the two sets of binomials with their coefficients, which then eventually ended up back to where we started. How can we put that into a process that we can follow every single time? Okay, I'm glad you asked. Let's try this. So let's first fill out all the information we know. A complex trinomial, is a polynomial in the same form of ax squared plus bx plus c. However, in this situation, a does not equal to 1. It's not allowed to equal 1 at all. If it did, then that'd be a simple trinomial, and we would just follow the same pattern from the last lesson. Now, how do we factor this one? Well, the good news is it's pretty much the same as last time to start with, but we have to follow an extra step. So we're going to follow a method. I want everybody to memorize this term. We're going to follow a method called decomposition. We're decomposing our expression into separate parts. So decomposition. Decomposition. So how do we do this? Well, we're going to find two numbers that add to b. Oh, we've done that before. We're good at that. We're also going to find two numbers that multiply to not just c, to a times c. That's where the difference is. If you think about the simple trinomials, wait, a was 1, so it's really the same thing. We just actually have to do something with the a now. Okay, so m plus n, that's going to give us b. All right, so we're going to find two numbers that add to b. Those same two numbers need to multiply to the product of AC. I don't know why it did that as an arrow. That's pretty weird. Undo. Whatever, we'll leave it as it is. Let's not complicate things. Okay, so once we've come up with those two numbers, do we just write our final brackets? We don't. There's a little bit more this time. This is where the decomposition comes in play. This is the decomposition step. what we're doing is we're decomposing the middle term into two separate terms that combine to get to that middle term. Okay? So in this case, you can see we're going to find our m and n, and we're going to break it apart, and we're going to combine it with the two sides of the remaining part of the expression. So our bx is going to become mx plus nx. And then we're just going to factor the expression by grouping. Oh, we know grouping. That's from 2 lessons ago. We can do grouping. Great. So let's give it a try. All right. So we have 3x squared plus x minus 2. So this is not a simple trinomial. It's a complex trinomial. That means I need to find two numbers that add to b. In this case, b is a 1. And we need two numbers that multiply to 3 times negative 2. Well, that's negative 6. Okay. Two numbers that add to 1 and multiply to negative 6. What are those two numbers? Well, it's still the same rules as before. If this is a negative, that means I'm going to have opposite signs. Okay? So let's try this out. 1 times 6, that's not going to get me to 1. 2 times 3, ooh, that might get me to 1. So in this case, we're going to have the numbers of 2 and 3. Now they need to be opposite signs in order to get that to be a negative. So which one should be positive and which one should be negative? Well, we have a positive in the middle, so that means we want a positive bigger term. So that means our 2 is going to be negative here. Okay, so with this in mind, now we decompose. So this is still going to be our 3x squared. We're going to leave that all alone. Now our x is going to get decomposed into two terms. The first term is going to be negative 2x. Actually, you know what? Let's write it. It does make a difference. I guess we can do it like this. I think for the first one, though, I want to keep it as simple as possible. So let's flip the order of these guys. Okay? So let's do 3 and negative 2, just to keep the first one a little bit easier here. So that means it's going to be 3x, so plus 3x, minus 2x. So we've just decomposed that, and then we put the last term back on, minus 2. Now we factor by grouping, which means we're grouping the first two terms, and we're going to group the last two terms. So from the first two terms, I'm going to factor out a 3x, because that's the greatest common factor here. So the 3x is going to go right here. And then we have, when I divide 3x squared by 3x, I just have an x left over. And the 3x divided by 3x is just a 1. Can't really do much else here. On the other side, negative 2x minus 2. Well, I can factor out an entire negative 2 here. That means I have negative 2x divided by negative 2. That's just x. Negative 2 divided by negative 2, that's a 1. So I can see that I have a common bracket. So that means that's going to be my first term, x plus 1. And my second set of brackets is going to be the combination of our two coefficients, our two multipliers, I should say, 3x minus 2. And there we go. We solved the problem. So that's the whole process. It's still the same as before, except we got this middle step now that actually, the middle step that actually does the decomposition. And then we factor by grouping, this extra little step here. So let's go down and let's try another one, okay? So we have 9x squared minus 3x minus 2. Okay, so I need two numbers that add to negative 3. And I need two numbers that multiply to 9 times negative 2, which is negative 18. Now again, I have a negative sign here. So that means that I'm going to have a positive and I'm going to have a negative number. I have a negative sign here, which tells me that the larger of my two numbers is going to be the negative. Okay? So in this case, what's my m and what's my n going to be? Well, let's think about this. What multiplies to 18 is going to add to 3? 1 and 18, not so much. 2 and 9, not so much there either. 3 and 6, that one will work. So the larger of our two numbers is going to be the negative. So that's going to be negative 6, and our other one's going to be 3. So now we can decompose. Now again, remember I told you that the order doesn't matter. I'm going to show you both versions here so you can see exactly what I'm talking about. Now this is going to make our video a touch longer, but I think it's worth it. So if we have m being negative 6, that means we have 9x squared. And that should be a squared. Yeah, there we go. And then we're going to subtract 6x. And now the next one, we're going to add 3x. And then leave the negative 2 alone. We're going to group the first two and then the second two. So the first two, I can factor out 3x from this. So this 9x squared is going to become 9 divided by 3, that's 3. X squared divided by x, that's just going to be x. Okay. And then minus 6x divided by 3x, that's just going to become minus 2. All right. And over on the right-hand side, what can I factor out of here? I can't factor anything. So I'm just going to add it up. 3x minus 2. I can't factor anything out of there. But you know what? Don't forget that there is a hidden 1 right here. That's actually there. So we cannot forget that that exists. So now when we do our grouping, our final factoring by grouping, our first term is our brackets. So in this case, 3x minus 2. Our second term is the sum of our two multipliers. So 3x plus 1. So that worked exactly the way we wanted it to. Now I'm going to show you the same result, but this time let's flip them two. Let's flip the two. So this time let's make m 3 and n negative 6. Okay, so we still have the same numbers. We're just going to do them in the opposite order. So that means our second step is going to look like this. 9x squared plus 3x minus 6x minus 2. Now, we factor out what we can. Again, here I can factor out a 3x. So this 9x squared becomes 9 divided by 3. That is going to be 3. X squared divided by x, that's just x. Now, 3x divided by 3x, that's 1. Now, over on the other side, what can I factor out here? I can factor out a minus 2. So this becomes 3x, and this becomes negative 2 divided by negative 2, a plus 1. Negative divided by negative is a positive. And then we combine. Our first set of brackets is our 3x plus 1. And our second set of brackets is the sum of the two multipliers, 3x minus 2. Look at that. We ended up with the exact same solution. It doesn't matter what order you put them in, as long as the signs are correct. Okay? That's the key here. So now that we have the hard stuff out of the way, let's keep going and do these. You may want to fast forward through this or run this at 2 times speed, just so I can move a little bit quicker now, because we're going to be here all day. So I want to find two numbers that add to 11 and multiply to negative 42. Okay? So in this case, I'm going to end up with an m of 14 and an n of negative 3. Okay? How did you get that, Mr. Lane? Opposite signs, bigger one is going to be the positive one. Okay? So now we have our 7n squared. We leave it alone. We're going to add on our 14n, and then we're going to subtract on our 3n and minus our 6. Find any common factors we can. In this case, the only common factor we have here is an n. So we end up with 7n plus 4. And over here, the only thing we can factor out is a... Oh, not plus 4. Did I make a mistake here? No, 14, negative 3, minus 3n, minus 6. Oh, that should be a 14, not a 4. There we go. So let's try this again. Because this is when I wing it and don't go for my notes. Sometimes I make mistakes. Let's try this again. And in this case, I forgot to write that as a 14, which messed up everything. So in this case, we actually have more than just an n can be factored out. An entire 7n can be factored out. So we end up with n plus 2. And the next one, we're going to factor out a negative 3. And that becomes n plus 2 as well. And now our first term is our brackets, n plus 2. And our second term is going to be 7n minus 3. Awesome. Let's go to the next one. Same idea. Two numbers that add to negative 17. Not the best number in the world, but it is what it is. And two numbers that multiply to 30. Okay? That's a positive, so they're both going to be the same sign. And that's a negative. That tells me that they're both going to be negative. Okay, so I got to find two numbers that add to negative 17 and multiply to 30. The obvious one is, of course, 15 and 2. Okay, so in this case, we're going to have negative 2 and negative 15. Does it matter which order? I can tell you that that 15 is going to go prettier with that 5. So I'm going to switch the order here. We're going to change this around, and we're going to do negative 15 comma negative 2. But again, the math will still work out the same way if we want it, if we work the other way. It's just a matter of making our life a little bit easier. So here, we leave our 5b squared alone, and now we're going to have minus 15b minus 2b plus 6. We group from the first two terms. I can factor out a 5b. Yeah, a 5b. And that's going to become just a b minus 3. And then the next one, we can factor out a negative 2. And we're going to end up with b minus 3 again. So we have our first term, which is our brackets, b minus 3. And our second term, which is the sum, 5b minus 2. Okay. So far, so good. We got two more of these before we get into something a little bit more complex. So we have 8x squared minus 13xy. So we have an extra variable in the mix now, so keep that in mind. And 5y squared. So we need to find two numbers that add to negative 13. And they multiply to 5 times 8, which is 40. Okay. So what are two numbers that add to negative 13 and multiply to 40? This is a plus sign, so they're both going to be the same sign. This is a negative, so they're both going to be negatives. So 40 and 1, no. 10 and 4, no. How about 5 and 8? 5 and 8, they add to 13, so let's use that. They're both going to be negative, so it doesn't really matter which one I do. But since I got an 8 there, I'm going to make the 8 first. So negative 8 and negative 5 are going to be my two numbers. So that means I have 8x squared minus, watch this, the y has got to come with this, okay? So minus 8 minus 8xy. And then on the next one, it's going to be minus 5xy. And then finally, plus 5y squared. You might be like, why do you take both the x and y? Because they're both here. We're decomposing this whole term, which means the variables are going to go with both values. Okay, what can we factor out? Well, obviously we can factor out an 8x. Okay, and that means we're going to have an x here, and we're going to have a minus y. Over on the next one, what can we factor out? I can factor out a negative 5y. Yeah, I can factor out a negative 5y, which inside is going to give me an x and a y again. X minus y. So our first term is our two brackets, x minus y. And our second term is the sum of our two multipliers, which is 8x minus 5y. That one was a fairly complicated one because you really had to think about where you wanted the m and n to line up to make your life a little bit easier. Again, it doesn't matter which order, your number would still work out to be the same thing. So we have 4a squared minus 8a minus 5. So we need two numbers that add to negative 8. And they multiply to negative 20. So this is a negative, so they're going to be opposing signs. This is a negative, so my bigger number is going to be the negative number. Okay. So what do we got? 1 and 20? No. 2 and 10? Yep, that makes sense. So that means if I have m is negative 10 and n is going to be 2, let's try this out. So we have 4a squared minus 10, minus 10a plus 2a minus 5. What can we factor out here? Well, I can factor out a 2a. I can factor out a 2a. So that means inside we're going to end up with 2a in here minus 5. And then over here, we can't factor anything out from the 2a minus 5, so we're just going to add that on. 2a minus 5. But don't forget, there's that hidden 1 right here. It's sitting there. It's not going away. So we have 2a minus 5 as our first term. And we're going to multiply that by the sum of our two multipliers, which is 2a plus 1. And there we go. So those are all of our complex trinomials. But what can make this a little bit more challenging? Another step. Imagine if we couldn't find any numbers that immediately worked out, or the numbers were too hard or too large or too complex to come up with all the different possible multipliers. So sometimes we always got to follow, well, not sometimes, we always need to follow that very first step, which is look for a greatest common factor. That never changes. In all these examples, we kind of ignored that because it wasn't necessary. But as you are doing this on an assessment or in real life, wherever you're doing this, depending on what your job is, yes, believe it or not, there are some people that need to do this for their job. You're always going to start by finding your greatest common factor. Look for a greatest common factor, or GCF. Okay? So before we do this hard work of factoring a complex trinomial, try and rip out anything that's common first. Okay, I'm just trying to. Perfect. That's where we'll go. So looking at this first one, 6m squared minus 14m minus 12. Is there anything that we can remove from all of these terms? Yeah, of course there is. All of those divide by 2. Is there any variable we can remove? No, there's no variable that's common amongst all of them. So the first thing we're going to do is we're going to find that greatest common factor, which is just a 2. It is what it is. It'd be nice if it were more, but it's not. So in this case, we end up with 3m squared minus 7m minus 6. Now we're going to factor out the inner brackets like we would a standard complex trinomial. That means we need to find two numbers that add to negative 7 and multiply to negative 18. Negative 18. This is negative, so it tells me they're going to be opposing signs. This is negative, which tells me the bigger of the two is going to be negative. That is going to be true no matter what. So 1 and 18? Nope. 2 and 9? Yep, that makes sense. 2 and 9 is going to get me to 7. So that means I have 2 and 9. And because this sign is negative, that means my bigger of the two is going to be the negative sign. So negative 9 there. So now we decompose. Leave the 2 alone. We're going to leave that all on its lonesome. Inside we have 3m squared. And now we're going to say minus 9. I don't need to rewrite it, but I can tell you that 3 and 9 are going to go much better together than 3 and 2. So I'm going to use the 9 right here. M, don't forget your variable. Plus 2m minus 6. Okay, we just work our way through. 2, what can we factor out from the first two terms? I'm going to use a set of square brackets here so we don't confuse ourselves. So I can factor out a 3m here. So 3m squared divided by 3m just gives me m. 9m divided by 3m just gives me 3. What about this next one? What can I factor out? I can factor out a 2. And now this is going to be m minus 3 in here. There's the end of my square brackets. I can get rid of the square brackets at this point because now I can combine my final step. So I have 2 multiplied by my first term, which is m minus 3. And then my second term, which is the sum of our two multipliers, 3m plus 2. And that's the process. You're going to keep following this exact same process. Remember, start with the greatest common factor. Once you've done that, start looking at whether it's a complex or simple trinomial. In this case, it is a complex trinomial. So what can we factor out? We can't factor out a 9 because 9 doesn't divide by, or sorry, we can't factor out a 6 because 9 doesn't divide by 6. But we can factor out a 3. So that means we're going to end up with 2x squared plus 3x minus 20. So now we need two numbers that add to 3 and multiply to negative 40. This is a negative sign, which means we're going to have opposing signs. This is a positive sign, which means our biggest of the two is going to be positive. So what works out? So 1 and 40, not so much. 2 and 20, nope. 3, nothing. 4 and 10, not quite. 5 and 8, yep, 5 and 8 will work. So we have 5 and 8, and we know the bigger of the two is going to be the positive sign, so that means the 5 is going to be negative. Okay, so leave our 3 alone. We're going to put some square brackets in here. Actually, we'll leave the square brackets for now. We'll put the square brackets on the next step. We know we're going to leave the 2x squared, and now we're going to decompose our 3x. Should I put my 8 or my negative 5 with the 2? I'm going to put the 8 because it looks like it has a better divisor. So we're going to say plus 8x minus 5x minus 20. Okay. Now, here come the square brackets. So 2x squared plus 8x. I can definitely factor out a 2x here. And that's going to become x plus 4. And then over here for the minus 5x and minus 20, I can factor out a minus 5. And this is going to become x plus 4. And now we just combine and finish our steps. So we have 3. And our first term is our x plus 4. Our second term is the sum of our two multipliers, 2x minus 5. There we go. And we're done. Let's go on to the next one. I know this video is starting to get long, but we're almost there. We're almost there. 4x squared minus 22x minus 12. What is the greatest common factor? 2, definitely. 4, nope. Any variables? Nope. So all we have is a 2. Okay, 2. Let's break it down. So 4x squared divided by 2 is going to give us 2x squared minus 11x minus 6. So we need two numbers that add to negative 11. Oops. And they multiply to negative 12. So this is a negative, so it's going to be opposing signs. And this is a negative, so the bigger of the two is going to be a negative. So what is the obvious one? The obvious one is, of course, what is the obvious one? Add to negative 11. So 1 and 12. Oh, yeah, I guess that makes sense. I guess that is the obvious one. And the bigger of the two is going to be the negative. So that means we have 1 and negative 12. Now, let's write it out. We have 2. And then our first term is going to be 2x squared. Now, do I want to put the 1 or the negative 12 with that 2? It doesn't really make a difference. I'm going to put the negative 12. Minus 12x plus 1x, so I can just write x, minus 6. Okay. Time to bring out our square brackets. We have 2. What can I factor out of this first set? I can factor out a 2x. So that's just going to become x minus 6. Can't factor anything out of x minus 6, so we just write it out, plus x minus 6. Don't forget the hidden 1 in there. That matters. There's a hidden 1 right there. So when we finish this off, we have 2 times our bracketed term, which is x minus 6, times the sum of our two multipliers, which is 2x plus 1. We've done this so many times now. Hopefully it's all becoming second nature to you, and you've already started fast forwarding this video or putting it into double speed or something like that, hopefully. All right, looking at the next one. What can I factor out? I can factor out a 2, of course. Can I factor out a 4? Nope, the 14 won't allow it. So we're stuck with just the 2. Any variables? Nope, just the 2. So the 2, so this becomes 8n squared minus 10n minus 7. Okay, what do we need? We need two values that add up to negative 10, and they're going to multiply to negative 56. Ooh, that's not a fun one, right? But it is what it is. So what can we come up here with there? Now we know that this is a negative sign, so that means this is a negative sign, so that means that they're going to be opposing numbers, opposing signs. and the larger of the two is going to be the negative. So let's think what we got. We got 1 and 56. Okay, that's not really helpful. 2 and 28. No. 3 is not going to help us. 4? What's 56 divided by 14? Yeah. So we have 4 and 14. Yeah, that'll work. 4 and 14 will work for the 10. So we have 4 and 14. Which one should be the negative? The larger of the two should be the negative. So 14, you get to be my negative. So let's write it out. We have 2. We have 8n squared. Now, do we want to put the 14 or the 4 there? It doesn't really make a difference. I think probably putting the 4 there is probably a better way. So let's say plus 4n minus 14n minus 7. All right. Now we have our square brackets. Now what can we factor out here? We can obviously factor out a 4n. So that 8n squared just becomes a 2n. And 4n divided by 4n is just a 1. Over in the next one, we can factor out a minus 7. So we end up with 2n. Oops, not 2x. Where's my eraser? Ah. This thing is so slow sometimes. Don't crash on me. There we go. Where was I? I factor out a 7. So this becomes a 2n plus 1. Now we just combine everything together. So we have 2 times our bracketed term, which is 2n plus 1, times our sum of our two values here, which is 4n minus 7. There we go. All right, so now we're going to do a callback to a couple previous lessons to solve a couple application problems here. So we know that the volume of this shape is specified by the following expression, 4x squared minus 10x minus 6. What we want to do is find the possible dimensions of this rectangular prism. We also know, because we took math in grade 2, that the volume of a rectangular prism is equal to length times width times height. So that's good. So those 3 multiplied values. We're going to use this when we're done. So let's start off by doing what we know. Let's factor this thing. So we have v is equal to 4x squared minus 10x minus 6. So we start off by doing the same thing we always do. Find a greatest common factor. In this case, we're looking at a 2. So now we have 2 times 2x squared minus 5x minus 3. Now we need to find 2 terms that add to the b term, which is negative 5, and multiply to ac, which is 2 times negative 3, which is negative 6. Now this is negative, so they're going to be opposite signs, and this is negative, so it means the bigger one is going to be the negative. So what is our numbers here, or what are our numbers here? So let's start off the basics. 1 and 6. Oh, we can make that work to 5, no problem. So we have 1 and 6. And because that middle one is a negative, that means our biggest number is going to be negative. Okay, so let's write it out. So we have 2 times, where was I? We're going to decompose this now. 2x squared. Let's put that one with the negative 6. Yeah, so we'll say negative 6x plus x minus 3. There we go. And now, square bracket time. 2. We're going to factor out what we can here. I can factor out a 2x from this 2x squared minus 6x. So 2x, and that's going to become just an x, and minus 6x divided by 2x is just going to be minus 3. Okay. The next term, we can't factor anything out from x minus 3, so we're just going to add it on. But, as usual, don't forget the little 1 there. It's still sitting there. So that means we end up with 2 times our bracketed term, which is x minus 3, times the sum of our 2 multipliers, which is 2x plus 1. So based on our previous knowledge, so since we know that the volume of the prism is equal to the length times the width times the height, which is a term times a term times a term, we happen to have 3 terms here. So these are our possible dimensions. Therefore, the possible dimensions are, we don't know which is which. There's no way of knowing that based on the information we have, but we do know that these are the possible dimensions. The possible dimensions are, we have 2, we have x minus 3, and we have 2x plus 1. Alrighty. So that's probably, that can be complicated depending on the shape that we give you. All right, last problem. This is similar to what we did in the previous lesson. So find 3 different possible values for b so that the expression 2x squared plus bx plus 9 can be factored. This is the exact same problem that we had before. We have to know the properties. Well, we know that to solve this complex trinomial, we have to find a number, 2 numbers, that multiply to a times c. So they multiply to 18. So we need to find 2 numbers that multiply, oh my goodness, that multiply, we're struggling here. Let's rewrite this whole darn thing. Delete. There we go. There we go. 2 numbers, slow down, that multiply to 2 times 9, which is 18. 2 numbers that multiply to 18. Okay, and we happen to know that if we find those 2 numbers, that the sum of those 2 numbers will be b. So b is the sum of those 2 numbers. The sum of the 2 numbers. Okay, so let's do a couple examples. What 2 numbers multiply to 18? Well, obviously 1 and 18 do. So that implies that b could be 19. What else we got? Let's throw a negative in there. We could have -2 and -9. That would imply that b is going to be -2 plus -9. That's -11. And let's do another positive one. Let's do 6 and 3. 6 times 3 is 18, which imply b is equal to 9. So therefore, 3 possible values for b are 19, -11, and 9. Are there more? Yep, there most certainly are. So that's it for our complex trinomials. We don't want to dig too far on that. There's lots of practice work for you to go on. We have one more lesson in this unit, which is factoring some special cases. And that's it for now.